Please, are you aware your screen has turned to anti-clockwise?
No.
90 degrees anti-clockwise.
No.
So your head is turned towards my left hand side.
Oh, really?
Yes.
Okay, let me see if I can turn it again. But is it okay now?
No. You are vertical on my screen.
Oh, I think I'm upside down. I'm upside down.
No, still is the same thing.
Oh,
yeah,
no.
No. Oh.
You've gone to the opposite direction. So come back 90 degrees. Come back at 90 degrees anti-clockwise. Go back anti-clockwise 90 degrees.
I think it's better.
You should go back anti-clockwise 90 degrees.
Okay.
All right. It's okay now.
That's okay. Yeah.
Okay. Okay, so please, we're ready. So we can start now. I started by mentioning that we had solved 3 out of the 4 questions, right? So today we are going to solve the 4th question, and if there's any other question that we also need to solve, we solve in addition. Is that okay? So
yeah,
I've opened my questions already, and I'm going to read. We're told that Mr. Amachi, chairman of AGOG's group of companies, has decided to apply a new method in assigning contributors to their product next year as a criterion for judging who should be given what type of product. Mr. Amachi reviews the past 2 years' experience in deals with these contributors on distributing evaluations, right, which were filled out by staff of the distribution team. Since each of the 4 distributors market 4 products at one time or another during the 2-year period, I'm reading from another screen. Amachi is able to record a product selling rating for each distributor. These selling ratings are shown in the table. So I'm going to do the table. I'm going to do the table so that we see the table. And then from there, we continue to find the best assignment of product to distributors to maximize the overall selling rating. And I mentioned in our last meeting that usually with transportation problem, you're either likely to maximize or minimize. And most of the examples we've solved so far, they are on minimization. So we have the opportunity of solving a maximization problem today, right? And that is so do I write from? Can I write from here? Product. Is that legible enough? Can you see it?
So your screen is too small.
It's too small, right?
Mr. Fortune.
Yes, please.
Good evening, sir. Good evening, sir.
Yes, boss. Good evening. Can you hear me?
Yeah, I can hear you. What
Okay.
do you choose on the board, either than the method you've been using?
Oh, I'm just trying out this to see how effective it will be.
And my screen small time, then you go off. Then you come back. When we are not
Okay.
seeing you, we go by the old method. It's even better.
Okay. So let's try this and see.
Small
So
time,
by the end.
it go for.
Okay. I'll try to write legibly now. So we have a product. And the products are A, B, C, and D. Right? And the distributors, we have 1, 2, 3. There are 4 distributors. Right. We have 90, 65, 95, 40, then 70, 60, 80, and 75. There is 85, 40, 80, 60. There is also 55, 80, 65, 55. So this is what is given, right? We're expected that from what is given, we should maximize this problem instead of minimization. All the problems we've been solving so far, they're all minimization problems, but with this one, we're going to maximize, right? We're going to maximize this problem. how do we solve maximization problem? First, you need to convert this to a minimization problem, right? Because ideally, right, we should minimize.
Hello,
But if you are
Mr.
given,
Fortune.
yes, please.
Please, I can hardly see your board. The figures on, I can see the board all right, but the figures on the board, I can't see.
You can see this 90.
If you can zoom it. No, I can see. I can't see them.
Okay. Who else cannot see them?
I don't know of other colleagues anyway.
But sir,
I can hear you.
hello. Yeah, your board is not stable. That is the problem. It's come to the bigger screen, then it go to, so the board is not stable. That's what I am experiencing here.
Okay.
Yeah.
Okay.
The rating is clear, but only the board.
So when you say it's not stable, I want to understand.
Okay, now it's okay. But small time to move to the top with a small screen.
Oh, okay.
Yeah.
Okay. I think I get what you're saying. Then let me pin it. Okay, I get what you're saying. So what I need to do is I think maybe it's a setting. So you have to mute your microphones, right? So I'll be the only one interacting in the meantime. Okay, good. Now to convert maximization problem to minimization problem, you look out for the highest, right, of the elements given. So we have here, this cell we have 90, 65, 95, 40, 70, 60. We have 90, 65, 95, 40, 70, 60, 80, 75, 85, 40, 80, 60, 55, 80, 65, 55. Now, of all the elements given here, because this is a maximization problem, the first thing you need to do is to convert this maximization problem to a minimization problem. And how do you do that? To convert the maximization problem to a minimization problem, you first of all look for the highest. So the first thing you do is to look for the highest of these elements given. Which of these elements given is the highest? So you look for that, and you see out of this, 95 is the highest. 95 is the highest. So since 95 is the highest of all the numbers, you have to subtract each of these numbers from 95. You have to subtract each of them from 95. That's the first thing you need to do the conversion, right? So let's subtract quickly. 95 minus 90 is 5. So this will be 5. 95 minus 65 is 30. So this is 30. 95 minus 95 is 0. 95 minus 45, 40 is, that's 55. 95 minus 70 is, I think, 25. 95 minus 60 is 35. 95 minus 80 is 15. 95 minus this is 20. So 95 minus 85 is 10. 95 minus 40 is 55. 95 minus 80 is 15. 95 minus 60 is 35. Then 95 minus 55 is 40. And 95 minus 80 is the same as this. Minus 65 is 30. 95 minus 55 is 40. Now we're going to prepare a new tableau using the values in red. So we're going to use these values in red instead. We're using the values in red, right? And so let's do that. So we're going to have, you can quickly write those out, but it's going to be, I have 5, 30, 0, 55, I have 25, 35, 15, 20, 10, 55, 15, 35, 40, 15, 30, 40. So I'm going to rewrite this. I've copied this out already. I think it's still showing in the background, right? So this is 5, 30, 0, 55, right? And maybe I should write it small so that I can have another space to write on. I think I can write here. Will it show? Yes, it's 5, 30, 0, 55. There is 25, 35, 15, 20, 10, 55, 15, 35. Then there's 40, 15, 30, 40. So this is what we're going to work on now. But what we're not told in the, from the question, we're not told which method to actually use. We're told to find the best assignment. So what do you suggest? What should we use?
Hungarian method.
Hungarian, right? Okay, so let's try the Hungarian. Okay, to do Hungarian, we begin by so we find the, or should we try the penalty? Okay, let's do Hungarian. We can do row reduction first.
Yeah, penalty is
Yes,
the shortest one. Why can't
which one
you
is the
use
shortest?
So let's try penalty. Penalty
Penalty
very
is the shortest.
is shorter. Yes,
It's
sir.
shorter. Penalty is usually shorter, but okay. So let's try. First, we can do the row reduction, right? So you reduce the rows. Row reduction. Now, this row, what is the list?
Zero.
0.
Okay. So what is the next thing we're supposed to do once we know that? You subtract it from?
All the other figures.
Okay, good. So this is 5 minus 0. As long as it's a 0, it means we're going to still maintain everything there. Is that right? You agree? You agree?
Yes, sir.
Yes, please.
Okay. Now in the second row,
Sir, go back again. You said the 5 is what?
I said here that what is the list here?
Sir, 0.
Yes. So 5 minus 0.
5.
Yeah. This minus 0. This one is the same thing. So I just rewriting it because the list is 0. That's what I meant.
Okay.
The next row, the list is 15. Is that right? So we have 15.
Yes.
25 minus 15 is 10. That is 10. 35 minus 15. 20. 0. 5.
5.
The next we have the list
0.
being 10. So 10 minus 10.
0.
0. So this is 45. And here is 5. And this is 25. 40, the list is 15. So 40 minus 15. 25. 15 minus 15 is 0. 30 minus 15. 15. 40 minus 15. 25. Now that we have this, we've done row reduction, we're going to use this and do what? Column reduction. So here, that is column reduction. Column reduction. So this time around, we're not going to move horizontally, but rather vertically. So we're going to look for the list. The list is 0, so it means we just rewrite everything here because 5 minus 0 is still 5. 10 minus 0 is 10. 0 minus 0. So this is 5. 10. 0. 25. Here the list is 0, so just basically write everything. So this is 30. 20. 45 minus 0 is 45. 0 minus 0, 0. Right? Here, we have 0 here. So the list is 0, obviously. So any number, 0 minus 0 is 0. Any number minus 0 is that same number. This is 5. And then 15. Right? So, but here will be different because we have 5 here. Because there's a 5 here, 55 minus 5 is 15. 5 minus 5 is 0. 25 minus 5 is 20, and 25 minus 5 is still 20. Right. What is the next step? Having got this, the next step is to cancel all the zeros with the least number of lines possible. So to cancel all zeros with the least number of lines possible. So how do you do that? I mentioned in one of our previous classes that first check for the number, the row or column with the highest number of zeros. Here, there's only one zero. There are 2 zeros here. You have 1 0 here. There's 1 here. Vertically, you have 1, 1, 2, 1. So if we have to cancel, this row has 2 zeros. This row also has 2 zeros. So we can cancel this row. Sorry, we can cancel this column or this row. It means we're using one line to cancel 2. If we cancel this first, it means we wasted that particular line because we use one line to cancel just 1 0, whereas we had the opportunity of using that same line to cancel 2 zeros, right? So now I would prefer we do this, but whichever you do is right. Okay, so now that we've canceled, let's still check. We have 1 here. We've canceled. We still have 1 0 here. We still have 1 0. Looking here, we have 1 0. No 0. There's no 0 here. Right? Here, we have 1. Here, there's 1 here. There's another 1. So they are all 1s. So it means we can cancel any of them and will not have any challenge. So you can decide that you want to cancel this, right? Or we have 2 zeros left. How do you cancel the other 2 zeros, right? Is either you do it this way, 1. Okay, so let's try this, and then do that. So we've used 4 lines to cancel all zeros. There were 5 zeros, but we're able to cancel the 5 zeros with just 4 lines, right? But does that end our solution? What is the dimension of the matrix we have here? This matrix is 1, 2, 3, 4 rows, and 1, 2, 3, 4 columns. So it's a 4 by 4. It's a 4 by 4 matrix. So the dimension of the matrix is just 4. So it means what? To reach an optimal solution, you have to have 4 lines canceling out. So once you have 4 lines canceling out, it means you can assign. So at this stage, we can assign. So let's do our assignment. Let's assign. So I'll rewrite this. Right. But in assigning, take note, we mentioned earlier on that in assigning, it's the opposite of the cancellation we're doing. Right. You're going to make sure that you look at the rows and columns. Always assign the row or column that has the least number of zeros. What that means is that you're certain that there's only one job, assuming there's only one for this particular row, you can see that assuming these ones are persons, right? There's only one person to do a certain job, right? So you can easily assign. And if you look here, looking at this vertically and looking at it horizontally, you still have you have 1 0, so you can assign this. So let's begin. I think we can assign this one. But let's make the work neat. I'm going to rewrite this here. 5, 10, 0, 25, 30, 20, 45, 0, 0, 0, 5, 15. Then there's 50. Okay, I think I'm a little far off the screen. Let's limit this 50 here. 0, 20, and 20. Right. Okay. So let's assign. This has 1 0. The 0 is here. But looking at it vertically, there are 2 zeros here. So let's not assign this for now first. Let's look at this. This is another 0. If you look at it vertically, there's another 0 there. So you have vertically, there are 2 zeros. Horizontally, there are 2. So leave that. Look for a 0 that has just one, a row and column. Like this, for instance, this 0 has just one column here. And if you look horizontally, there's no any other 0. So we can assign this first. We can do this first. Once you assign this, it means that you have to strike out everything here. Cancel out. If we look at the next 0 here, vertically, there's no any other 0. Horizontally, there's no any other 0, so we can assign. So let's assign this as a second. You do that assignment, strike out, cancel out. Then we move here. If you look at this 0, vertically, there's another 0 there, so leave it. Let's look at this one. If you look at this, vertically, there's no other 0, but horizontally, there's 1 here. What about this one? Okay, so we can, let's assume that we want to assign this one. What other factors do we need to consider in doing our assignment? What other factors do we need to consider? You can look at the original question, the data given the original question. This position, remember how to maximize. In the original question itself, this position where 0 is occupying, it's 95 that was there, right? This other 0 here in the original question, it's 75. 75 was here. But what about this position? This position, we had 80. We had 80 in this position. We want to maximize. So ideally, if you're to maximize, which of this should you take to maximize your rating? I would take 95 instead of 80 or 70, right? So let's take this one as our third, and then strike out, strike out. So it means we have no option than to do this one as our fourth. So these are fourth. So we have first, second, third, fourth. So what is our best assignment of distributors? Our best assignment of distributors is to, the first, for instance, remember we had, this was distributor 1, distributor 2, the third distributor, the fourth distributor, and the product A, product B, product C, and product D. Right. So how are we supposed to distribute? So basically, we do this. It's supposed to be 3A. So I'm erasing this portion. If you don't mind, I'm erasing here. I'll write my assignment. Assignment, we have 3A. Second is 4B. Third is 1C. And the fourth is 2D. But so you now have to go back and compare to the original. In the original, we had, so let's write the original table we're given. In the original, the problem itself here was 90.
Sir, can you please come back again for the assignment?
Yes.
The assignment.
We have first, I will explain how we assigned or.
Hello, sir.
Yes, please. Are you asking? You said we should. You want us to explain this again?
No, the assignment that you write, you have 3A.
Yes, yes.
You have the 3.
Now, if you have your question, if you printed out your question, you see that you're told that there were 4 distributors and 4 products. The distributors were horizontal and the products were vertical. So there were 4 distributors. The distributors were called distributor 1, 2, 3, and 4. But the products were product A, B, C, and D. Now, once we got to this page, we want to assign distributors or products to distributors, right? So that's why we did this from here. So this particular position, you see that the first position is what row? Is in the third row. 1, 2, 3 is row 3, column A. That's the first column, which is A. Yes. And this one here is 4th row, 2nd column, which is B. Here is 1st row, 3rd column, which is C. Whilst here is 2nd row, 4th column, D.
Okay, I get you, sir. Thank you.
Okay, good. But
So, sir, the last one will be 2D. 2D, not 2C.
Yeah. Oh, sorry, I repeated the C. Sorry, it's D. Right. So this is 3A. Okay, so I want to rewrite the original problem we're given. This is 70. I know you have it already. 85, 55, 65, 60, 40, 80. 80, 95, 80, 80, 65. Then we have 40, 75, 60, 55. 40, 75, 60, 55. So just locate them. In fact, we can even compare. You see that what was the first? Third first, so it was here. So this is 85. What was the second? Our second was 4B, which is 4B. 4B is here, is 80. Our third is 1C, which is 95. And our fourth is 2D. 2D, which is 75. 75. Now we can add this up. So let's add up. 5, 5, 10, 15. 9, 17, 26, 30. Is that 33?
33.
Okay. So this is 3, 3, 5. And that's it. Remember, you're not told which method to use. But had we used penalty, we'll still get the same answer, right? So that's it. Okay. I think is that another question? I think
Yes, sir.
is it the one?
The other one.
Is that power?
No, sir. The other one.
Which other one?
Sir, we have 4B.
Peter.
We have 4B. 4B and 4C. Penalty method. C. Look at it.
No, but what I have only ended here.
No, we have 4B.
What is 4B?
We just solved question 4, isn't it?
Yes.
4A, 4B, and 4C.
Okay, I can see that. I can see B.
Yeah.
Yeah, I can see it. I didn't scroll to the other page. If each rating is 200, how much will be the total selling rating? Each rating is 200, right? How many ratings do we have? How many ratings?
335.
335.
So if we have a total selling rating of 335, and each of them is 200, what is the total selling rating? So B, question 4B, total selling rating is equal to 335 times, we're told that each rating is 200. So multiply that by 200. That's it. So this would be 300 times 2 is 670, right? 670. Then we add this 2 zeros. Is that correct?
Yeah.
Is that 67,000?
Yeah,
67,000.
Okay. So that's it.
67,000.
Mr. Fortune,
Yes, please.
you see that we didn't read the question. That's why you were saying which method. The method is Hungarian and Czech with penalty.
Okay. Compute. Okay. I didn't read it. Okay. No, I read it, but I didn't check the other page. So we can now check this answer using our penalty method, right?
Oh, but hello, good evening.
Yes, sir.
Yeah, I think that one is 4C.
Yes.
The first is the one saying compute the minimum rating using Hungarian and check with your answer using penalty method. That's the question about 4C. So
Yes.
does that mean we'll go back and do, or that's what we've already done?
Okay, no, that means we've used one method, right? we're asked to find the best assignment of product to distributor to maximize the overall selling rating. We've done that, but we used what? Hungarian. We use Hungarian. So what do we do? If you're asked to compute the minimum rating using Hungarian and check with your Is that okay?
Yeah, exactly. That's it.
Sir,
So let's do penalty.
Sir, a question.
Yes.
Okay, concerning the maximization,
Yeah.
we first of all reduced the whole, we deducted the whole numbers from the highest.
The highest. That's what you
Would
need
that-
to do first. If the problem is a maximization problem, you need to do that first. So
Okay,
you're
would that
converting.
answer the A?
Yes.
Would that answer the A?
Okay, let's see. Find the best assignment product. No. No.
So if
In
that
fact-
will not answer the A, now
Yes.
listen to me, sir. If we have not reduced everything by deducting all the numbers from the highest, would I have any change on the answer? What if I use these numbers on the table direct by using Hungarian or penalty? And at the end of the day, I still choose, when I come to, how do you call it, the A, excuse me, let me look at my table. If I come to 3A, it still
Yes.
give me the same 85. If I didn't reduce all, and I still choose the original table, the values,
Yes.
must it change the answer, the final answer?
Okay, your final answer may not be this one. In fact, I've erased, if I hadn't erased, I would have predicted what the answer would have been. It means that instead of selecting the bigger values, you rather do the opposite. You would have rather selected the smaller values. So the smaller values are 55, 40, 60, and so. You have ended up selecting those answers. And maybe instead of 85, you probably would have selected 55. Instead of 80, you probably would have selected 40. Instead of 95, you probably would have selected, say, 60. So by the time you add them, it will be smaller than this value. Yes. You get my explanation?
Sir, I got it, but what I mean is, if I've not reduced it and I use Hungarian method straight away without reducing it, at the end of the day, I will still come back to choose the original. Would that have any effect?
Yes.
Okay.
That's what I'm saying. Even if you're going to still choose from the original table, you not select the big values. You rather be selecting the smaller values.
No, I mean where I have not changed the values by deducting from the highest. If I've not changed, I just use it directly like that.
Yes.
Okay.
It will affect your values. So that's what I'm saying. Without reducing the maximization problem to a minimization problem, without that conversion, your answer would be different, likely, highly, highly likely. And that would be, in fact, you'll be doing the wrong thing.
I think you can give it a try. I think you can give it a try after the classes. So
Yes,
that
you can try
for
and see.
himself.
Yeah. Okay. So do you have any other question?
yes, sir. He left with 2 questions. P. The first question that he gave to us on the first meeting. Peter.
Yes, sir.
Yeah, he gave us on the first meeting when we meet, he gave us some 2 questions.
Is Hungary and the penalty?
Yes, yes.
Is it the ones that came in the picture?
Yes.
Yeah, in the government.
Oh, okay. I think
So
someone
that's of it.
someone just sent that to me again. Someone just said, not just Bauer sent it.
But have we, sir, have we answered the normal question 4, number C? I mean, section
Using
C.
penalty. We've not attempted penalty yet. Should we do it?
Yes, I think we must exhaust this before we move to another one.
Yeah.
Okay,
So let's finish with the question 4.
Okay, so let's do the penalty. Okay, the original tableau we're given, was for maximization. We reduced it to minimization and had this. Where do I write from? I think if I write here, you can see. So I can start writing from here, just at the top. So we had 5. Let me make this a little bold. We have 5, 30, 0, 50, 5.
Yeah, hello, Mr. Fortune.
Yes, please.
Yeah, are we not going to use the original one, the 1965, 9540 for the with the penalty method? Are we not going to use the original?
No, we are maximizing. So
giving the question.
No, don't use it. Don't use it. Use what you reduced, the converted one. We converted the problem we're given from maximization to minimization. So that's what we're going to use. We're using this one.
Okay.
Yes. Right. This is what we have here. So we're going to use the penalty method. So we're going to do, this will be row penalties. Row penalties and column penalties. So the penalties here are the column penalties. Right, so let's begin. How do you get the penalties? You have the lists and next lists. What is the list here? 0. What's the next list?
It's 5.
Are you there? Okay, good.
Yeah, we are here, 5.
And 5. So what's the penalty? Is the difference between the list and the next list. So that is 5 minus 0. 5. Maybe I can use a different pen to write. Okay, I'm using my black. 5. List is 15. 15. Next list is 20. 20 minus 15. 5. List is 10. Next list is 15. Difference is 5.
Mr. Fortune, I'm confused.
Okay.
If you deduct 5 from 30, you get 25 or 5.
This is 0.
It's taking the list.
Okay. Since you're confused, let me start over. But you don't use 30. 30 is not the next list. The list here is 0. 0 is a number. The list is 0. And the next list is not 30, but rather 5. So 5 minus 0 is 5. The list here is 15, next list is 20, difference is 5. List is 10, next is 15, difference is 5. List is 15, next list is 30, difference is 15. These are the row penalties. The next one, let's do the column penalties. What's the list here? 5, next list is 10. So the penalty is 10 minus 5, which is 5. For column 2, the list is 15, next list is 30. Penalty is 30 minus 15, which is 15.
Hello, sir.
Yes.
Your screen is not visible to some of us.
Okay. Is it for a reason?
I don't know whether it's the
Yeah, I
network.
think some people have put their mics on. So once a while, then
Okay.
it comes on.
Yes. So
unmute
that's why I said
themselves.
just mute it. Anytime you talk, mute it at once, and then you don't have that problem.
I think Bacha and one Simon K before always their mics are unmuted.
So just mute it. Once you mute it, it won't come up. If it comes up, it blocks the original video. But I can do a setting. That setting, not now. I can do a setting that only my screen will always show. But not now. It will take time. It will delay us. So let's move on to the next. 0
Okay,
and...
sir, question.
Okay.
The column. Hello,
Which of the
sir.
columns?
Question, the column reduction that we are, the column reduction. That's
Yes.
the five that you write over there.
You-
The original, the reduction that we did, is it not 0 over there? When you check 10, 40.
Uh-huh.
The original.
Okay, what I have here, what I wrote out when we copied first is 5,
Yes.
30, 0, 55, 25, 35,
Yes,
15,
yes.
20, 10, 55, 15, 35, 40, 15, 30, 40. Yeah, so this is what I have.
Yes.
So how do we get the penalty for the third column? We look for the list, which is 0, and the next list is 15. 15 minus 0 is 15. List here is 20. Next list is 35. Difference is 15. Now we have 4 column penalties and 4 row penalties. Which of all these 8 penalties is the highest? Anyway, we have 15 here. 15, 15, 15. So we have 4 15s. Which of them should we use? Right, at this stage, you can always make reference to the original problem given, right? So that you select the bigger ones, the one that gives you the bigger values. So let's see. If I select this 15, select the 15, then go back and assign. Ideally, when you go back to assign, you assign the list. Go back and assign the list. So what is the list here? 15. So assign this one as a first. Once you do that assignment, you cancel out these ones and cancel out horizontally and vertically.
Hello, sir.
Yeah, hello.
Hello,
Yes.
sir.
Yes.
Sir, with the column penalty, we have
Yes.
5, 15, 15, 15. Why do you choose to take the first 15 on the 30, 35, 55 column? Not
Okay, that-
rather. Okay, you are looking at the highest figures.
Okay, but this would have been better, right? I think this would have been better instead.
Yes.
Because we
Yes.
have 0 here, and 0 is smaller than
Yes,
15.
sir. Yes,
Good.
sir.
That's good.
Uh,
Yes. So I think we should have rather assigned this one instead of this. And if you look at this, these are bigger values. When assigning, go back to the Tableau, assign the lists, right?
Yes, sir.
Okay, so that's good. So I want to assume that I've not canceled this one. So I'm going to rather cancel. I'll rather use this as first.
First, yes, sir.
I'll cancel using, okay, let me cancel this way now. Cancel the row and the column. Sorry, cancel the row and column, right? So you see all others are left. This hasn't been assigned. You've done the first set of penalties. Do the same. Find this next set of penalties. You've canceled everything here, so dash. Here, you've only canceled out 15. It means the list here is 20, and the next list is 25. The penalty is 5. The list here.
Mr. Fortune.
Yes, please.
You know, getting 15, 15, 15 on the column, and then also on the row 15.
Yes.
The method of choosing, how do you call it? The first, it confuses me a little.
Yes, so that's what I'm saying. Anytime you're assigning, right? Once you know the penalty, you've got your penalties, and you're able to identify the highest penalty, right? Then you can go back into the Tableau or the matrix here, and for instance, we have to look at this 15, right? This 15 belongs to which of the columns? It's this column. It belongs to the third column. And because the 15 belongs to the third column, what do? Right? You go back to the third column and look for the lists element in that column. There's 30, there's 15, 15, there's 0. Which of them is the list? It's 0. Right? We could have taken this one. If we take this one, we have the list here to be 15. What about this one? The list 20. Which of these three, 0, 15, 20, is a list?
Okay, understood.
That's it. So that's why we selected that. Okay, so our next rounds of penalties. So the list is 10, the next is 35, difference is 25. So because 35 minus 10, the list is 15, next is 40, difference is 25. That is 40 minus 15. Here, 5 has been cancelled out already. So we have 10, list, 25, next list. Difference between 25 and 10 is 15. List is 15, next list is 35, difference is 20. List is, okay, cancelled. 20, 35, 15. Of all of this, 15, 20, 15, 25, 25, 5 is, which is the list? Here the list is, no, we're not looking for the list. Anyway, when you do penalties, you look for the highest penalty. So the highest penalty here, there are 2, 25, 25. But going back to the matrix itself, if this is 25, look up here. We have, look for the list here. It's 10, so we can assign 10, right? And then for this particular one, we can assign 15. Which of the two is the list? 10, right? So let's rather take this one. So we're going to assign this as our second. But when you assign, you cancel out the row and that column. Right. Next round of penalties cancelled already. Dash 35, 20, difference 15. Right. Cancelled. 15. No, just 15. Another one. Here. Cancelled. 35, 15, 20. Cancelled. Once cancelled, continue to cancel. Once cancelled, continue to cancel. This is 20 and 40. 20 and 4. Remember, this wasn't cancelled. 20, 40, difference is 20. So the highest penalty, there are two high penalties, which are all in the column. So what do we do? Let's assess. This is 20. Go back here. We have to allocate 15.
Sir.
Yes, please.
But the row deduction method, we have 15 here, we have 40 here. Why are you saying that here is 15? Well, here is supposed to be 25 with the row column.
Okay, sorry. It's not 15, it's 25.
It's 25.
The difference between 15 and 40 is
25.
40. Yes,
yes.
25. Thank you. The difference between 15 and 40 is 25. So there's no need going back to check this. We just take this because it's higher. So that come back here. We have 15 and 40. Which of them do we assign? The list of the two is 15. These are third. Then you strike out completely. We're rather left with this. There's no need to do the penalties again. Just assign this one as a form. What did we get initially? Remember we had, we can compare it to our previous answer. This is 1C. We had 1C then. 1C. This is 3A. We also had 3A. This is 4B. And 2D. When you cross-check, you're going to see that your values are the same. You still have the same values. You still have the same values. Looking back for 1C, what is that 1C? Look at the original. 1C here, I'm looking at another screen. 1C is 95. Three A is 85. 4B is 80. And 2D is 75. And then we had, what did we get? Wasn't it 335? That's as easy as A, B, C. Right?
So unfortunately, this is the question 4C, right?
Yes.
It's question 4C.
4C, yes. We are cross-checking to be sure that what we had is the same using a different method. So that's it.
Yes, sir. Yes, sir. Yes, sir. Mr. Fatu.
Yeah, okay. Yes, I can hear you.
Okay, the question 1A and then question 2B.
Yes. What about it?
Because it's confusing. It's a assignment.
Yeah, okay. Yes, I can hear you.
It's a minimization procedure. How will you treat as a maximization problem?
Okay, how would you treat a maximization problem? Convert the maximization problem to a minimization problem before you apply all the other methods or techniques. So you have to convert the maximization problem to a minimization problem.
Please, which question are we talking about?
He's asking questions. So let's go to the next question. We are running out of time.
Yeah. I've answered your question.
My brother, I disagree with you. Somebody is asking a question. Allow him to ask the question. If you are saying that you are running out of time and he doesn't understand, then what is the benefit of him being in the class?
So we are sending the questions Saturday, and tomorrow we don't have class. So what are we doing?
But you should have a way of saying
it. You will send it the video.
Just rubbish
the video.
The purpose of this class is not only
because
to
you
assignment.
have understood it and he has not understand it, and you are rushing it. It's not nice. But the way we present it is not the best way of presenting it.
Masa, are you the one talking?
Hello.
Are you the one talking?
By he has spoken.
Hello.
My brother. He has spoken.
Yes, Peter, I can hear you. I can hear you.
Please, we beg you, class. What the guy was asking, when I asked you the question, I don't think the guy knew where. So he was. I want to just mention that it is question 2B, so that he will go and refer from his questions. That was the question he was asking. When I asked the question, he didn't know where the question came from. So it came from question 2B.
Yes, so he was right. He was right. Okay.
And then the question 1A. That one too.
Yes.
We have no idea.
Okay, but that one, when you Google that, there are a lot of options, right? You see where you just Google, there are a lot of them there. Okay, that's it, right? Do we have any other question to answer?
Yes, sir. Yes, sir. There are situations where concerning assignment, you see a job 4, but the people you assign the job for are 3.
Yeah, so you have the same situation with transportation, right? Where in the case of transportation, we don't care whether the number of rows are not equal to the number of rows is not equal to number of columns. But as long as the demand is equal to the supply, for transportation problem, we are okay. So in transportation problem, it may happen that you have maybe 4 rows, but 5 columns. right? You have 4 rows, 5 columns, but you check the supply and check the demand. If the supply and demand meet, right, they are equal, then you're good to go. But if they are not equal, you need to make sure they are equal by either adding a dummy row or a dummy column. But with assignment, that is not the case. With assignment, you have to ensure that the number of rows equal the number of what? Columns. So that in the assignment, if you're given 3 rows and 4 columns, you would have to, given 3 rows, 4 columns, you would have to add 1 row to make that 4, because the number of jobs should be equal to number of personnel. Is that right?
But sir, we need to get one example to see how it goes.
Oh, just add zeros. You add zeros to. Okay, let's do something here quickly. I can erase this, right? Assuming you have this. Look at this, for instance. How many columns are we having here? How many rows? We have 3 rows. And how many columns? Just 2. This is not balanced. It's not. So what do? Make sure that M is equal to N.
Sir, Mr. Fortune,
Yes.
you know,
Yes.
with assignment, there is the one you said a guy sent to you. There is one particular one which has the same thing. If you can solve that one.
Okay, so let me check. Right.
The one the guy sent to you, or I can mention it to you here too.
Okay, I have another screen I'm watching, so I can look at the questions. I think it was Bauer. I think Bauer sent it. Okay, I've seen that. This one has P1, P2, P3, P4, and M1, M2, M3. So this is balanced. Use Hungarian and penalty. So the first one is balanced. Let's see the second question. In the second question, okay, the second it's not. So you need to balance it before you proceed. So let's just look at the second. We'll not solve everything because we've solved this a number of times. So we just check A, B, C, D. There is 1, 2, 3, 4, 5. A,
What is happening?
Oh.
Have we lost the lecturer?
Relax, network problem. Relax.
COVID-19 8,720. Ah, installation 17,000. Application 1,000. Work 4.5. 23,000. Taxable or
Sorry.
oh, yes, sir.
Uh, is it network problem or what?
Yes, I will call you. I'm sure. Yes, I will call you after the class.
Okay.
This network too is challenge everywhere.
Do ti do re do la re so. Do ti do re ti la so do. No mi re do la re so. Oh, so 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 far. So far.
Are we in a music class now? Hey.
Oh, Master, sorry. Oh. Sorry, I was just taken away. Sorry. And I'm not sure this class will continue again. The way I'm looking at things, it's almost 10 o'clock.
Why don't you call him so that he will record it and send to us tomorrow morning?
Okay, let me try contacting him and see.
Because we'll be submitting it over the weekend, so tomorrow.
His line is not going through. Maybe.